Hey everyone. So, have you ever asked an AI a question and gotten an answer that sounded completely plausible, totally confident, and was just flat out wrong? Yeah, me too. That strange and, let's be honest, kind of frustrating phenomenon is what we're digging into today. AI hallucinations. So that's the big question, right? It's not just that the AI gets things wrong, it's that it does it with such swagger. In this explainer, we're going to pull back the curtain and see exactly what's going on under the hood. And get this is a perfect and very real example of the problem. Someone asked a popular chatbot for a specific dissertation title. Instead of just saying, hey, I don't know, it just invented 3 different titles, confidently. And of course, all of them were wrong. It was trying to be helpful, but it ended up just making stuff up.
Okay, so let's put a formal definition on this. An AI hallucination is a statement that sounds totally believable, but it's false and it's delivered with a high degree of confidence. The key thing to understand, and we'll see this again and again, is that this isn't a bug in the usual sense. It's actually a fundamental part of how these systems currently work.
So why do these plausible-sounding lies even happen? Let's get right into the root cause, which, believe it or not, has everything to do with how these models are taught to think. And this is absolutely crucial to grasp. This isn't some random glitch in the matrix. It's a direct consequence of the rules of the game, the way we train and evaluate these AI systems. In a way, we're actually encouraging them to behave like this. So what is this main cause? Well, the best way to get your head around it is with an analogy you'll probably remember from school. The AI is basically just training to pass a test. So imagine you're taking a multiple choice test. You only get points for correct answers. If you come across a question you don't know, what do? You guess, right? A bold guess gives you at least a chance at getting points, while admitting you don't know, leaving it blank, guarantees you get a 0. AI models are in the exact same boat. They're incentivized to guess rather than ever say, I don't know. And this table shows you how that plays out in the real world. Just look at these 2 models. The older one, O for Mini, actually has a slightly higher accuracy rate at 24%. But then look at its error rate, a whopping 75%. And why is that? Because it almost never abstains. It just guesses on everything. The newer model, on the other hand, is way more cautious, and its error rate is nearly 3 times lower because of it. So here's the takeaway. When you only reward accuracy, you basically encourage strategic guessing. The model learns that to get a higher score on the leaderboard, it's better to just take a shot in the dark. And that behavior is what directly leads to more and more hallucinations. Now, this all stems from the AI's most fundamental task. At its very core, a language model is just playing a simple game: predict the next word. So, during its training, a model sifts through just a mind-boggling amount of text from the internet, and it learns patterns. It gets really good at the consistent rule-based stuff like grammar and punctuation. But what about random arbitrary facts, like a person's birthday? There's no linguistic pattern to learn there. So when it's forced to predict anyway, it often just invents something that looks like a fact. This sums it up perfectly. There are rules for where a comma should go, so an AI can learn that pattern and be right most of the time. But there are no rules for predicting a specific random fact, like someone's birthday, just from the words around it. Trying to do that is just a guessing game, plain and simple. Okay, so if the tests are the problem, how do we fix them? Well, the good news is the solution is actually pretty straightforward. It's all about changing the rules of the game. And here's the solution. We just need to change how we score these models. We need to punish confident wrong answers more than we punish them for admitting uncertainty. It's the same logic used in some standardized tests, the ones that subtract points for wrong answers to stop you from just guessing blindly. It's all about rewarding what researchers call intellectual modesty. And this new understanding helps us bust some really common myths. No, hallucinations are not inevitable. We can totally train models to just say, I don't know. And it's not about making models bigger and bigger. Sometimes a smaller model is actually better at knowing its own limits. And finally, this isn't some mysterious ghost in the machine. We actually understand the statistical reasons why this happens. So let's wrap this up by talking about why getting this right is so critical for the future of AI, and for all of us who are going to be using it. Ultimately, this shifts the entire conversation. The goal shouldn't just be to build the AI with the highest score on some accuracy test. The real goal should be to build the most reliable, the most trustworthy, and, in a way, the most honest AI, one that actually knows its own limits. And let's not forget this number, 75%. That's the real-world cost of a system that rewards confident guessing over cautious honesty. This is what happens when we prioritize the appearance of knowledge over actually admitting uncertainty. And that leaves all of us with this final really important question. As we keep building and weaving these powerful tools into our lives, what do we want to reward? The illusion of a perfect, all-knowing machine? Or the quiet confidence of one that's smart enough to just say, I don't know? It's something to think about as this technology keeps evolving. Thanks for joining me.